Today we are going to discuss problem number 2654, minimum number of operations to make all array elements equal to 1. So basically you are given a zero indexed array nums consisting of positive integers. You can do the following operation on the array any number of times. So select an index I such that I is greater than or equal to 0 but less than n minus 1 and replace either nums of I or nums of I plus 1 with their GCD value. Now you have to return the minimum number of operations to make all elements of nums equal to 1, and if it is impossible, return minus 1. So the definition of GCD is the GCD of two integers is the greatest common divisor of the two integers. So here let's understand what the problem statement is saying with this first example 2634. So we have 2, 6, 3 and 4. So problem statement saying is that from I equal to 0 to I is equal to n minus 1. So you can select any I and you can replace that number or the number next to that, the I and I plus 1. You can replace any of this number with the GCD of this number, GCD of 6 and 3. So the GCD of 6 and 3 will be 3. 3 is the greatest number which divides 3 as well as 6. So you can replace either 6 with 3 or you can replace 3 with 3. And suppose I replace 6 with 3. So after one operation it will become 2, 3, 3 and 4. So now problem statement is saying that you can perform this operation any number of time. But after, what you have to do is at the end you have to convert this array into 1 1 1 1 all ones. Now if this is possible to convert, you have to find the minimum number of minimum operations to do this, and if it is not possible then you have to return minus 1. Okay, I suppose you understood the problem statement. So let's take this example only and understand how we can convert this into all ones. So here if you see the GCD of 3 and 4, it's going to be 1. So we can replace either 3 or 4 with 1. So let's suppose we replace 3 with 1. So now we have 1 1. Now I can GCD of 1 with any number n is always going to be 1. So I can either choose these two numbers in next operation or I can choose these two numbers. If I choose this number I can convert 6 into 1, and next time if I choose these two number I can convert 2 into 1, and next time if I choose this number I can convert 4 into 1. So it will take 1, 2, 3 and 4 operations. So we have to find like is this the minimum number of operation? What if when we took the GCD of 3 and 4, instead of replacing 3 with 1, if I replace 4 with 1, what would happen? It will become 6, 2, 6, 3 and 1. Now again in order to convert 3 into 1 I have to take GCD of these two and I will have to do this. If I have to convert 6 into 1 I will have to take these two and convert 6 into 1. If I have to convert 2 into 1 I will have to take these two and I will have to convert this into 1. So you see the number of operation is always going to be, minimum number of operation is always going to be 4. Maximum number of operation could be anyone. I can choose 2 and 6 and I can replace this with this. Again I can choose 2 and 2 and the GCD is again going to be 2. I can again keep doing this only. So here you can see that if we have any one present in our array, then I can always use the choose the adjacent numbers with that one and convert those numbers into 1. So if we cannot get any one in our array, or we already do not have any one, then it will not be possible to convert all the numbers into 1. How will we know that we cannot get any one in our array? That would be GCD of all the numbers, that is 2, 6, 3 and 4. So if the combined GCD, that is the GCD of all the numbers in the array, is greater than 1, then it is not possible to get any 1 after doing any number of operation, and hence it will not be possible to convert the whole number into ones after any number of operations. So here you see, if there are any numbers or if there are combination of any numbers whose GCD is going to be 1, then whole array GCD is at the end going to be 1. So if there are numbers like this 2, 6, 2, 4, something like that, here in this case you can see the GCD of these is going to be this. Let's suppose we remove this, and GCD of this is also going to be 2. The GCD combined GCD is also going to be 2. So 2 and 6, this will result in 2. Then this 2 we take GCD with another 2, it will again result into 2. So the combined GCD is not going to be 1. So if the combined GCD is not going to be 1, then it is not possible for the array to be converted into 1 after any number of operations. So there is one case, the total GCD. If this is greater than 1, then it's not possible. Otherwise it's possible. Otherwise we will have two conditions. If suppose there is already 1 present in your array, and second case is 1 is not present. So if GCD is equal to 1, then in that case, if 1 is not present, it's possible that we would be able to convert few numbers. After few operations, we would be able to get at least one. So if 1 is present already, that we already saw here, that irrespective of how you make your operation, so in 3 and 4, whether you convert 3 to 1 or whether you convert 4 to 1, you're always going to have to do at least x number of operations, and that x is equal to number of non-ones element present. So every non-one element has to be converted into 1, and if there is 1 present, we can do exactly that x number of operations to convert those numbers into 1. So if there is 1 present, and suppose there are one number of ones present in our array, so in this case 2, 6, 1, 4, 5, 1, here nums1 is going to be 2. So in this case we have 1, 2, 3 and 4 number of non-ones, and hence we will have to perform exactly 4 number of operation to convert the whole array into 1. So irrespective of whether you start with this one, you do this one, or you do this one, every number has to be converted into 1, and that can be done using adjacent number. So suppose this 6 can be converted into 1 by taking these two, and then in next operation this 2 can be converted using this one. So when 1 is present, your answer is always going to be n minus num1, because these are the number of non-ones present. When 1 is not present, then you will have to first get 1, and after that you can just perform n minus 1, because there are total n number of numbers and you have already 1. So this is number of 1 is 1, and after you get 1, you can perform this number of operations to convert whole array into 1. So suppose this is y, you have to perform y number of operations to get at least 1, and after y operation you have to do n minus 1 more operations to convert remaining numbers into 1. So this is going to be your answer in this case. Now how will you get y? So y you will have to keep minimum. So suppose you have this example 2, 6, 3, 4, 2, 6, 3, 4. So here you see 3 and 4, these two number their GCD of 3, 4 is 1. So I can just choose these two number and perform one operation to convert this into this, and after one operation I will have 1 1. So answer for this will become 1 operation. Your y here is 1, so answer will become 1 plus n is 4 minus 1 with, so answer is 4. Let's take another example. So let's take 3, 6 and 2. Now the GCD of 3 and 6, it's 3. The GCD of 6 and 2, it's 2. But the GCD of 6, 3 and 2, it's 1. So I can, in first operation I can take the GCD of 3 and 6 and I can replace it with 3 and 2. In second operation I can take the GCD of this 3 and 2 and I can replace any one of them to 1. So if there are 3 numbers like this, I had to do exactly whose GCD, whose combined GCD was 1. So I had to perform, like, let's suppose this size was m, so I had to perform m minus 1 number of operation to get at least 1. So we have to find like the smallest interval whose combined GCD equal to 1, and let's take that interval size is m. So m minus 1, this is the number of operations we will have to perform to get at least 1. And then n minus 1, this is the number of operations we will have to perform to get all remaining, to convert all remaining non-ones into 1. So in our problem statement you can see that the size of number is 50 only. So we can, if we have this, suppose I 0 1 2 3 and 4, so I can always choose this. I can start from here. I can choose this different sizes of windows. Then in next iteration I can start from here and I can choose this size, this size, this size, this size, like that. So for in n square time I can get every interval GCD. So every interval GCD, so whichever interval gives me GCD of 1 and whose size is smallest, I will take that size as my m. So in this example you see that smallest size, smallest interval with GCD equal to 1 was this 2. In another example that we took here, the smallest interval whose GCD was 1 was 3. So we can find this smallest interval whose GCD is 1. We can do m minus 1 operation to get at least 1 and then we can do n minus 1 operation to convert all the numbers into 1. So at the end we have a given array n. We can find GCD, total GCD. If total GCD equal to 1, then we have two conditions. Find the ones, number of ones in our array. If this number of ones is greater than 0, then our answer is simply n minus this 1. If there isn't any 1 present, then we will have to find the smallest interval whose size is m. Then it will become m minus 1 plus n minus 1. Answer m minus 1 to get at least 1n, and then for remaining n minus 1. And if this total GCD is greater than 1, then just return minus 1 because it's not possible. Yeah, so let's see the solution. You can see the solution is very small and simple. We iterated in our nums and we found the total GCD and total number of 1. If 1s is greater than 0, then n minus 1s. Otherwise, if GCD is greater than 1 total GCD, then it's not possible, so we return minus 1. Now we find the minimum interval. So for I first loop, it iterates from I equal to 0 to I is equal to n. So I is our starting position. Then second loop iterates from j is equal to I to j less than 1. So basically we are checking the interval from I to j. So we fix I and we keep increasing our j, and we find the combined GCD. If any GCD is 1, then we update our minimum interval. So in case the minimum interval is higher, we update it to lower value. And at the end, after these two loops end, we will have the minimum, the smallest interval whose GCD is 1, and this will be m minus 1 plus n minus 1, our solution. Thank you so much.